Innovation Day breakthroughs. Yeah. So let's start today's session with a small poll. So, what is the role that best describes you? So, engineer or designer, project manager, so IT professional, and so so you have 3 minutes for this poll, so you can try attending the question. So next we shall start with the webinar. So I can see most of the attendees are from engineer or designer's role. Okay, so I'm just closing this particular poll. Uh, so I just want to know what challenges the engineers are facing. So I have another question being launched here. So what is the biggest challenge that your team is facing? So I just want the engineers as well as product managers to take up this particular question. So this will be open for another 2 minutes. So let's try to know the major challenges that are faced by the industrialists. So I'll be closing the poll in another minute. Okay, I'm just closing this the poll. So you can see most of people find their challenges managing design equations and as well as collaboration across departments. So definitely yes, in today's webinar we shall see how we can address these two major challenges. And so last but not least, I have a final question. So I just wanted to know how many people are aware of this particular platform called 3D Experience platform. So I just want you guys to answer this question as well. So now I'll be closing the poll and let's start with today's webinar. Okay. So by this particular poll, I just got to know that most of the people are familiar with the 3D experience platform. So that's really a good thing to know. So for those people who are not familiar or who would like to know more about it, so today's session is exactly for you guys. So let's start with today's webinar. So this is going to be today's meeting agenda. So wherein we'll be discussing about the industry challenges and trends. So the solution case studies, power hour, and the key takeaways. So, so what are the major industry challenges and the trends? So first and foremost thing is, are you guys able to meet the deadlines with precision? So most of the companies face their challenges with submitting their projects on the time or maybe planning the deadlines of the projects. So are your designs cutting edge and at the state of the art? So most of the people struggle in finding the state of the art designs or achieving the final designs which they actually dreamt of when they started doing their designs. So next thing is, are you able to transform your ideas into reality with a remarkable speed? And next, so do you guys exhibit exceptional design agility and adaptability? So are you guys able to deliver outstanding returns on investment? So these are the major industry challenges and the trends that we'll be addressing in today's webinar. So let's start with the session. So in today's webinar, we'll be considering the Resmin Bolter assembly as a case study. So which is a company that manufactures large vehicles or automobile heavy duty vehicles for mining and other operational activities. So here will be trying to design a knuckle component that exactly fits for this particular assembly. So now let's start with the solution show case studies. So in today's solution case study, so we'll be taking different stages of the project launches. So first we'll be starting with the project kickoff, and next with the mechanical design, and next how we'll be validating our designs using the simulation options, and next how we can bring this particular model into marketing and other activities, and next closing the loop on the final presentation. So let's kick off with the project. So having an organized approach for managing your project is a key requirement for most of the companies. Maybe managing the existing assets when working on parallel projects, or maybe
while when we are trying to cross collaborate between different departments based on the dependencies of the tasks. So these are some of the major challenges that's actually killing more time and exceeding the deadline submission of the projects. So now let us see how we can manage these things using the 3D experience platform. So here we have something called as a project planner. So that helps you in planning the milestones of your project. So where you can have a Gantt chart kind of an appearance. So that gives you a complete summary of the project. So as well as you can create a number of tasks, manage your schedules, set up your deadlines, as well as plan your tasks accordingly and share it across the team members, so that you can have a complete overview of the completion of the project, where you're standing with respect to the project and what steps you have to take further to make sure the deadlines are being met at a earlier stages. So all these things can be pretty much easily managed with the help of the project planner app. And also it helps you in collaborate between different departments and manage your works. So next to start to see like what happened, what all we can get from this project planner app is that so we can effectively manage the project, as well as we can meet your deadlines and handling the dependencies. So creating dependencies in the sense, like if we take a simple scenario where we'll be creating the part models initially, and next we'll be doing the assembly of it, and only after the assembly and part modeling is done we'll go for the drafting. So here we follow a series of actions while completing the project. So whenever you need to create dependencies between these particular tasks, so those things can be definitely managed over there. So at any point of time you come across a scenario where your deadline is being preponed or postponed, so which is the task that's being more affected and how you can actually manage on that. So all these things can be pretty much easily managed using the project planner app. So the next part comes with the mechanical design. So let's start with the design part. So the first agenda of the design comes in create and store. So here you can see, so in this no, regularly use SolidWorks user interface itself. So towards my right pane, so I have been able to access to the 3D experience platform. So here I have been assigned a task from my manager. So to create a component, to create a knuckle component for the assembly. So here I have some of the attachments being added from the management level. So which are available in the form of slides, and I can completely go through the slides over here and across the visual representation of the model, so without even opening the model. So that's how lightweight the 3D experience platform is, and that's how it's gonna help us or hold our hands while managing on bigger projects and bigger models. So here, based on the observations being added in the slide, so I would like to start working on my component. So I can also start commenting over here on the task to communicate with the management, indicating that I'm going to start working on the task. And with the help of the attachments being added over here, so I can directly drag and drop the file that I need to be working on. So the advantage of task management app is that irrespective of the file size, so it can be from MBs or GBs, so you can readily select the file that I can add it as an attachment, and the same can be taken by the designer to start working on the further designs. So whereas if we take up the traditional email process as an example, so where uh, will have multiple restrictions wherein will not be able to add large size of files over there. So whereas this is an exact replacement that we can consider for a email kind of an approach. So now that we have taken up this particular model, so now let's start working on our further designs. So next part is so I just want to create a knuckle component over here. So I'll be taking up my part template for the designing, and then let's start doing our designs. So initially I'll be creating a simple circular sketch over here. So and I'll be defining the dimensions as per my need. So next I'll be converting the sketches from 2D to 3D. So with a simple dynamic push and pull approach. And also we can make use of the traditional extrude command, as well as we can make use of the dynamic push pull approach to create these kind of profiles. So the same profile can also be copy pasted from one plane to another plane, thereby indicating the faster approach. And with the help of this dotted lines, which definitely helps me in adding constraints at the uh, drawing level itself rather than adding it separately. So next here I would like to convert this particular 3D 2D profile into 3D as well. And next I'll be adding some referral lines over here. So the construction lines helps me in getting uniformity among the sketches. So next I want to snap the edges of this particular rectangle on the edges of the circle. So thereby creating dependencies in such a way that at any point of the time the diameter gets updated automatically, the rectangle length is also going to be updated. So other than following the traditional method of mirroring, so I can activate the mirror command at the sketching level itself, so that what sketch I draw on the other side will also be replicated on the opposite side, so thereby completing the 2D profiles. So next I want to constrain these things by adding some dimensions, and next I want this particular dimension to be somewhere close to 90. So now with the help with the black color indication, so SolidWorks indicates that the profile is completely constrained, and it's ready to go for a further approach, that is converting the profile from 2D to 3D. So now I would like to add some materials over here using the extrude. And another thing that we can observe over here is that, so using a single sketch, so we have been able to do two operations. One is adding material as well as removal of the material. So next I want some extra faces over here, so which I can definitely delete it at a single click and make sure the unwanted faces have been deleted and patched at a single click. So last but not the least, I would like to add some fillet profiles here. So with the help of the smart selection option, I can select similar kinds of edges in a single click, and I can add the fillet profiles for the model. So now that we have completed this one, so we can add some custom properties and also make sure whether it's going to be a buy product, make product, and define its properties over there and save it onto the platform. So now that I have created this component, so I would like to save this particular component onto the platform. So before that, I would like to create a drawing for this. So SolidWorks provides the right pane, so wherein you have all the traditional orthographic views readily available, so which we can readily pick and place onto the drawing sheet and we can project it. So we can make sure we can add different visual styles to every individual views. And next, as we have already defined the dimensions at the modeling level, so there is no need for us to redefine it again. So we can make sure we can call back the same dimensions over here and definitely add it over here. So now that I have completed creating of this particular drawing, so I would like to add some description over here. And once the description is being done, so I would like to save this back to the platform. So whenever I'm trying to save it, so I have something called as a bookmark, so where I'll be selecting a definite particular bookmark and I'll be saving the model. So what is the use of this particular bookmark? So for example, so if we are following the traditional methods of saving, so we usually follow internal folder structure methods, so wherein we'll be saving the folders at one particular area or an address. So same way it can be replicated on the platform as well. So here we have something called as a sharing, external sharing option. So most of our customers find a challenge. So whenever they are sharing their particular CAD models to their vendors, so they don't want them to edit it, or they don't want them to have any access to the internal components of the assembly or anything as such. So in those scenarios, whenever we have a need to collaborate with our external holders, so in that scenario, you can share the file by adding some conditions over there, that is maybe restricting the files or restricting the commenting access, and then you can share it across them in the form of a simple link, so that they can open by using the same link. Your counterpart or the vendors can open up the model and they can start reviewing the model and give you feedbacks on the updation part. So now we just saw in the create and store how we were able to view the collaborative tasks and how we previewed the markup exactly inside the SolidWorks window itself in the task pane, and we created new part components, and also we created drawings and saved it to the exact address or the bookmark location where I actually wanted the model as well as the drawing files to be located. So now let's move further to the further stage of the design, so that is assemble and reuse. So now that we have completed creation of the 3D model, so I would like to create an assembly of it. So now I'll be taking the knuckle component into assembly environment. So here with the help of the smart search command, so I can check for any particular file. So here I have already used a bearing in one of my existing assemblies. So I don't know the name of the bearing, so but I know remember the name of the assembly. So I can search for the assembly name over here, and with the help of the relationship app, I can make sure find out the parent-child relationship and what file I need to exactly use in my current assembly can be readily taken up from over there. So now that I have added this bronze bearing or the flange bearing over here. So next I want to transfer some of the properties from flange to the component. So we call it as a smart feature. So wherein I can transfer the extrude cut option from the flange bearing to the active knuckle component. So that whenever you're using any fastness or any point of time you want to transfer the some of the features from one component to its adjacent meeting component, so that can definitely be done by using the smart features option. And this particular updation or the transfer of features will also be reflected at the part modeling level. So now let us see how it's going to be reflected at the drawing level. So now we can observe, so the SolidWorks maintains an associativity between the part modeling, assembly, and drawing files. So what changes we have done at the part modeling level or at the assembly level is definitely being reflected at the drawing level also. So now I'm have taken a section view to make sure I add the dimensions of the groove cutting over there. And once these particular things are done, so next I'll be saving the data back to the platform with the latest updates. So now that we have added this one, so I would like to add some more components. So I'll just take up an expander pin and I'll try to do an assembly over here. So based on the geometry of the profiles, the SolidWorks automatically suggests us the possible mates that can be added between the components. And next, I would like to make sure this fits exactly at the center. So I'll be selecting the respective faces and I'll be adding an advanced width mate over here. So similarly, I would like to add the same kind of a width mate over here. But SolidWorks also provides us with the version control options. So wherein I would like to make sure I use another configuration of the same knuckle component over here, knuckle kit. So the same thing can be changed at the time. So now I would like to add a wear plate. So I'll be searching for a wear plate over here in the direct search. But with the help of 6W tags, so you can say I'm getting n number of wear plates over here. But by adding more and more filters, automatically the search list gets reduced. So this will be definitely helpful for us for a filtered search option. So rather than the linear search option that we have been regularly using in the Windows user interface. So now that I have added this particular component or the assembly is being done, so I would like to mention some of the custom properties or updates over here. And next, it is going to be saved back to the platform. So here I'm gonna name the knuckle kit with the proper title, and I'm gonna save it in the same exactly selected bookmark location. So bookmarks are nothing but the address where we are trying to save the files or the files of maybe the models or the drawings. So now let's have a recap of what we saw in the assemble and reuse session. So here we have we just tried to make an assembly from the part. So reused the flanged bearing via relations, and next we inserted the connected design library components, and we used the 6W tags to filter the source wear plate, and we saved the assembly onto the platform. So now let's move to the further next stage, that is the check and revise part of the designing. So in the check and revise part, so now that we have completed the assembly, so now let us see how this particular assembly fits into the main boom assembly. So I opened up the main boom assembly over here. So I'll be importing the knuckle kit assembly or the components over here. So I want two knuckle kit components to be added at for the two boom cylinders available over there. So now that I have bought this one, so I shall zoom to the area where I want to add those knuckle components and mate it. So with the help of by clicking on Alt command, so we can make sure activate the smart mates so that we can add multiple mates at a single click. And next I would like to mate it with respect to the boom cylinder. So I shall select this concentric faces and add a concentric mate over there. And the same thing is going to be repeated across the other cylinder as well. So now that we have completed adding this particular boom cylinder, so now let us validate the moving part of the movement of the boom cylinder. So here we can observe that the cylinder guard is actually restricting it. So next I would like to make sure the same uniform appearance is going to be added onto the component that I have added. So I can copy paste the appearances directly live on the go. So now I want to check for the interference detection to make sure there is no congestion between the components, and I find there are no interferences available between the entire of the assembly. And next we shall check for collision detection. So even the collision detection options are available at the evaluate of the SolidWorks. So here when I try to move the component, so whenever my component is colliding, so that definitely gives me an alarm over there. So here I can observe that the cylinder guard is actually restricting the degrees of freedom or movement of the boom cylinder. So which has to be altered or changed over here. So now let us see how we can actually manipulate or the change or maybe redesign on the cylinder guard part. So here I'll directly launch for the relationships app and check whether the cylinder guard is being reused in any other assemblies. So here I have the cylinder guard component. So with the help of the same relationship app, I can find out it's being already used in another uh, assemblies over here. So the challenge over here is for us. So whenever I try to make some changes in the cylinder guard, it's gonna be reflected across the other components as well. So what is the best possible approach I can consider over here? So the best possible approach that I can consider over here is adding a new revision or maybe creating a new revision of the cylinder so that the old revision remains undisturbed in all other parent components, and whatever changes or updates that we are making in this particular current cylinder is going to be updated only with respect to this particular project or the assembly. So after creating a new revision, so I'll be making sure adding some dimensional changes over here, and once these dimensional changes have been done, so I'll just check for the same collision detection again. So now we can observe that the cylinder guard is not restricting the movement of the boom cylinder. So with the help of revision management, so we were able to create a new revision, so keeping the older as parent assembly models undisturbed. So next that we have completed all these models, so we shall save the updated assembly components onto the platform. So I'll just go for unlock all the lock components and I'm gonna save it onto the platform. So what is the concept behind the locking and unlocking? So most of the times when we are working in groups, if I am trying to create a boom cylinder, so there will be another co-worker of mine or maybe a colleague of mine who will be trying to design the knuckle component. So at the end of the day, we collaborate and do the assemblies over here. So whenever the whatever components that I am trying to create or maybe edit, so those components need not have to be edited by another engineer or a co-worker, so thereby creating a restriction on duplicacy of work. So for that particular thing, so we have this locking and unlocking options. So whenever I want to work on any component or edit on it, so definitely I'll have to lock that component in my name and start editing on it, and other person will be able to edit on the same component only after I unlock the files and push it back to the platform. So now let's just revise on what we saw in the check and revise session. So we just logged the boom assembly and we inserted the knuckle kit component. So we commented onto the teammate about the update of the work, and we utilized the relations app for the cylinder guard, and we created a new revision for the cylinder guard, making sure the other parent assemblies are undisturbed, and we saved it back to the platform. So now let's check on the other stage of the design, that is updating and documentation. Just a moment. Yeah. So now I want to make sure that I want to change the revision over here. So you can see here, so the expander pin doesn't have any grooves being added. So but now I want to make sure I update my document with the latest revision. So there are some more revisions of the components being done. So how do I replace on my existing model with the latest revisions? So based on the user's choice, whether they want to use the latest revisions in their assemblies or maybe stick on to the older revisions, so we can definitely update it over here. So just with a simple click, so we can make sure the latest revisions are being updated. So now here, so we want to make sure there are some grooves being added to the knuckle component, which is nothing but the latest revision that has been done or updated on that particular expander pin. So now you can see just by clicking on the update on latest revision options, I've been able to make sure the grooves are being removed at the component level. So next, we shall try to create an exploded view of the assembly. So creating exploded views are also pretty much simpler in SolidWorks, just by creating just with a simple push and pull approach. So we can make sure the positions of the components are being placed and we can update it. So we can also create an animation of it and export that animated video in the form of MP4 format for further verification or analyzation purposes. So next we shall create knuckle component for the a drawing for the assembly of the knuckle component. So here I shall make sure I add the top and front views of the component, and here I want to add a isometric view of the expanded exploded view of the model. So and also I can make sure I can arrange or change the overview of it or the view orientations and also the visual styles. So next I want to add bill of materials. So bill of materials can be added at assembly level, individual part level, and as well as sub-assembly level based on the user's need. So next, after adding this bill of materials, so I want to add some auto ballooning for this one, which defines the balloon IDs. So the placement of balloons also has wide varieties of choices, so where you can place it across and around the components. So now that we have created this final knuckle kit assembly as well as the drawing of the knuckle kit assembly, so next is that we shall save all these updated documents onto our platform. So in platform we'll be saving it at the right bookmark location, indicating the components are addressed at the specific area. So now I'm going to add the latest deliverables over here. So initially, if you observe, we had the boom assembly added as an attachment. So now I am adding deliverables, that is the drawing. So whatever work I have completed, so I'll be adding the deliverables to the task and I'll be moving the state of the task from in work to completed. So thereby the person who has assigned me a task gets to know that I have completed the task, and he can directly open that particular task over there and check on the deliverables for further verification and changes or anything that has to be updated on the further process. So now let's see what we saw in the update and the documentation session part. So just by the simple check-in and check-out by the user, we were able to take up the models and update it. So we created some exploded views, and we also created some assembly drawings, and finally added the automatic balloons and BOM and saved it back to the resume bookmark. So the next part of the next part of the process comes with the issue management. So most of the times, once we have completed all our designs or the scenarios where the designs have been released and it goes to the manufacturer. So once it goes to the manufacturer, so we might the manufacturer might feel like if some minute changes are being done in the designs, so he can manufacture the component in-house and there will be a reduction in the procurement, the list of the components that has to be procured from external will be reduced. So in those scenarios, the manufacturers can raise an issue by using the issue management app. So just like how we added the markups earlier, so similarly we can add some markups over here for creating issues. So here I have a simple example. So where the manufacturer is trying to add some markups for the slide and he's going to create an issue for the particular slide. So he can he can take snapshots of it and add it onto the slides, and he can add some symbols over there, or maybe add some markups for the areas where the design changes or updations has to be done. So with the help of the text, we can also add some comments over there. So here, what I would like to do is I want to increase the number of counts of that particular transmitter. So I'll be adding it or attaching it to the circle that has been marked up over there. So next, once this particular part is done, so next I would like to uh, create it in the form of an issue and launch it onto the community page, or maybe assign it to another engineer to work on. So here I'm just creating an issue for this particular, creating a new issue in the markup environment itself, so that the project manager or the main designer is going to understand. So what are the changes that has to be done over here? So now that the issue has been created, so now let us see how we can address those issues. So here we have a scenario where multiple issues have been raised from the manufacturing team or the counterpart. So next, what we would like to do is we would like to add some of the change actions over here. So we can also add the components based upon which the issues has to be managed, or the things has to be updated. So here we'll be moving the maturity state of the issues from to do to in work, indicating that so we are already started working on the issue. So we can create a new change action over here, so which records the steps that have been taken to resolve the issue, or we can consider it as the solution steps that are considered. So once the change action has been created, so which particular designer or assignee has to work on this change action? So the worker is also being assigned over here, the person who needs to work on it, and the person who needs to approve it, as well as the person who needs to have a notification about the updates of the change action. So here I'll be turning on the cap of the cap over here, indicating the recording of the change actions being done. And once the component is being completed or updated, so next what we shall do is we can we can move the maturity state of the change action to be completed. So thereby completing the change action, we have been able to complete the issue as well, addressing all the necessary changes to be done. So that's how you can make use of the issue management app to collaborate between your manufacturing team, or maybe collaborate between the cross departments in your organization, and also have a uniform record of the changes being done with respect to the product from its scratch, that is at the designing level, to the final release level, and also having updates on what changes have been done and what are the steps taken to address those particular issues. So now what we saw in the issue management is that we just created issues and markups. We shared and sharing of issues on the community. And next we just planned on the change actions to address those particular issues, and finally completed the change action as well as thereby completed the issue as well. So the next part of the next part of the design cycle is that the simulation part, or maybe the design validation. So here I have the same knuckle component being taken, and here I would like to make some design validation or run some simulation on this particular component. So before that, I want to hide all the toolbox components. So there, wherein I'll be hiding all the toolbox components by using the selection option. And next, I'll be activating the add-ins in the SOLIDWORKS environment, and I'll be running a new study for the simulation. So initially, first and foremost, I need to define the geometry. So here I'll be considering this particular cylinder faces as my fixed geometry, and the wear plate is going to be a slider geometry. So here I'm going to add a sliding mechanism on the wear plates over here. So once the boundary conditions of for the simulation are being designed, so next thing is we shall add some loads on it. So here the load is going to be acting on that particular face, so I'll be selecting the particular face upon which the load is going to be acted, and define the quantity of load that's going to be added over here. And once all the boundary conditions have been defined, so here next we shall run for a simple simulation study. So the simulation takes a tetrahedral meshing approach, so where it completely breaks down the component into single individual components, and then runs the pressure or the boundary conditions on every individual component as well as the assembly level. And once the simulation is being run, so it also solves the component and gives us a visual representation of the report. So here we can also check for stress analysis, so where you can see with the scale over there, and the displacement or the strain analysis. And next also would like to check for factor of safety. So here I'll be adding another factor of safety option over here, and here you can see, so this defines the breakage point or the design area where I have to rework on my model. So here we can observe that we have some red color indication that the factor of safety is not defined at the corner fillet levels. So now what I need to do is I need to make sure this particular corners have been readdressed. So I'll just try to make the changes over here in the assembly environment itself by entering into the part editing mode. And next I'll be defining the radius of the fillet over there. So once the design changes have been updated, so next thing is I would like to run the same simulation study. So there is no requirement for me to define all the boundary conditions from scratch again. So whatever boundary conditions that I had earlier defined at my initial stage, so same boundary conditions can be rerun on the updated model. So now we can observe that. So once I go for the factor of safety, so all those areas where the design changes has to be done or the rework had to be done is going to be completely safe. So we can see most of the areas are in blue, indicating the safety of design, and the areas where we had the red color indication for the factor of safety threats have been completely eliminated now. So in the design validation part, we just checked on about the stress analysis, strain analysis, the factor of safety, and next part is going to the market. So now that we have done our designing as well as we have done on the worked on the simulation part, so next thing is how do we get this product to the market? So how do we make sure people get to know about how we can actually present this product into our customers or the uh, entire world? So first we'll be starting with the real-time render tools that helps us in creating photorealistic images for the CAD models that we have created. So here I have a simple example or a scenario. So wherein I have two images. So wherein one image is a DSLR captured image and another one image is a CAD rendered image. So let us see which one is actually a CAD rendered image. So you can see the left one is a CAD rendered image and the right one is a DSLR captured image. So that's how close we can expect the outputs of visualize with respect to reality. So similarly, I have another image over here, so which defines the interior designing of a room. So wherein one part is a DSLR captured image and another one is a CAD rendered in the using the visualize tool. And similarly, I have a coffee dispenser machine, so which has a for DSLR image at the left hand side and CAD rendered image at the right hand side. So let us see what are the different kinds of visualization outputs that we can expect from the SOLIDWORKS visualize tool. So here I have a simple small video clip that defines about the outputs that we can expect from the visualize. So it can be from a simple lighting effect to an interior, or maybe the animation or the motion study. So all these things can be definitely done on the visualize part. So here we can observe that even the environmental animation can also be done over here. So this is just a quick glimpse on the capabilities of the visualize tool. So isn't that impressive? So here I have a simple animation done for the assembly. So where it defines how the assembly is being done using the visualize tool. So these are the kinds of animations that help us impress our clients whenever we are trying to present our completed models, or maybe for creating your marketing contents, or also publish these particular videos on your websites or your uh, presentations. So now we just saw how we can create the realistic renders using the visualize tool. So whenever you need to create a user manual for your component, so how do we create those particular user manuals? So definitely we have a tool that helps you over there. that is the SolidWorks Composer. So here we have, I would like to take you through the live presentation for the Composer part. So I'll just go to the app over here. Yeah. So here I have the Resmin boom assembly that I have taken. So here you can observe, so I have created some multiple views over here. So which indicates the operational setup for the components. So just by getting into this particular views, I have been able to move the component. So similarly, I can check on the animations as well. So whenever at any point of time you want to create some uh, and whenever you want to create some user manuals, so that can be definitely achieved by using the composer. So maybe some technical illustrations, or maybe when you want to create assemblies on how to do assembly of the component, or how to do disassemblies of the component, or maintenance manuals, user manuals, all these things can be done on the composer. So here I have the main Resmin boom assembly that I have taken. So here I have to replace some of the components. So how do I replace the components? So I can just directly select for the view over here, and also I can switch between different views by creating interactions. So here I want to check on how the maintenance part of it. So here I have another view added over here, so I'll just directly click on the maintenance view, so which gives me a clear idea about the maintenance part of the components. So next I would like to go back to my home view, and next here I want to see the operational features. So I can directly select the operational features over here. So just by clicking on the buttons over here, so I can make sure the component moves. So these are the kinds of interactive contents that you can create to your own CAD modules and use it for further elaboration or illustration of the part components. So other than creating these kinds of views, or maybe the bill of material parts, so here I have created this particular component with a silhouette representation. So next I want to define or give more details on the internal parts over here. So you can create n number of views over here, and also next here I have created a bill of materials. So whenever I hover my cursor over the bill of materials, the component gets highlighted. So that's how you can create bill of materials and also know more about the usage of the components. So you can create n number of bill of materials, and everything can be done over here. So this is one portion of the composer. So we have other uses of composer as well. So wherein whenever you want to provide different choices to your customer. So here I have a simple example of an interactive content created in the composer. So wherein you can publish these kinds of contents on your website to know the opinion of your customers. So how this particular cycle looks in blue color. So how the particular cycle looks in yellow color. So in white color and red color. So how the combination works with different types of handles. So these kinds of options that you can give to your customers by publishing the contents on the websites, so that you get to know what are the customer demands and needs that they are actually expecting from your company as an output, so that you guys can stand parallel along with the changing trends and get to know more about the customer needs and requirements. So other than that, we can also create animations over here which defines the usage or maybe the maintenance of the components. So these are the outputs that we can expect from the composer. So other than this, so last but not the least, if you would like to create a walkthrough animation, so if you're working on some larger assemblies or interior factory kind of a setup, so you can definitely expect the best output from the composer in terms of walkthrough animations as well. So here I have a simple example of a textured city that gives you a clear idea about the walkthrough or the fly through animation. So this is a CAD model that I have taken. So, and here I'm trying to create a walkthrough animation using the composer tool. So whenever the camera walks on the streets, we call it as a walkthrough animation. So whenever we make sure the camera flies above the ground level, so we call it as a fly through animation. So based on the designer's need, we can create either a walkthrough type of animation or the fly through kind of an animation. So now let's get back to the PPT. So these kinds of user manuals can also be created on the Composer tool. So you might have come across these manuals whenever you purchase any gadgets on online. So maybe on Amazon or Flipkart. So any gadgets you purchase. So these are the maintenance manuals. So we call it as self-explanatory manual. So wherein just by looking into the pictures and the text being added over there, so we get to know what are the updates that how to use that particular gadget or the device, and we can start working on it. So these kinds of manuals can also be created along with advanced animation outputs. So here we just saw using the technical documentation, so how we can create the interactive document, technical illustrations, and accelerate time to product market using the visualize as well as the composer tool. So closing the loop, so looking at the industry trends or challenges we saw earlier, so how these challenges are going to be addressed on 3D experience platform. So to meet all your deadlines with precision, so we can make sure by the adoption of project planner app, so this particular challenge is going to be completely eliminated. So to get the cutting edge design and state of the art, so we have SolidWorks along with the browser based designer tools that helps you in achieving the final designs. So you can transform your ideas into reality with remarkable speed with the help of share and markup options available on the platform. So you also can exhibit exceptional design agility and ability with the help of the change actions as well as the issue management and the uh, collaborative lifecycle app options that is available on the platform. So we just saw how the manufacturing team was able to give updates to the design team to make sure the issues have been resolved. So last but not the least, so all the outstanding deliverables as well as the return on investment can be definitely achieved with the by adoption of 3D experience platform into your design cycles. So now let's start with the Q&A session. So if you have any questions, you can just post it over there in the comment section. So we have 5 more minutes for this. Yeah, I have received a message from Sharavanam. Hello, sir. So any questions you have or any doubts you have over here, so which you would like to discuss? Here we have a question from Rajesh Kedar. So in simulation, can we solve nonlinear contact? So we have advanced options in simulation, so which comes as a separate bundle, so we can do it over there. But with respect to the simulation option that I showed over here, that is inbuilt in SolidWorks Premium module. So there we will be able to do only up to linear simulation as well as linear static analysis and FEA analysis over here. So in what format can we save composer output? Can we share it in common formats like PDF or exe drawings? So Composer usually saves its file in .smg format, but whenever you want to share it across the other team members or clients, so you can share it in the pack and go format. So wherein along with the Composer, so we have the Composer viewer tool, so that gets packed with the file, and whenever they try to open the file, so it's like 1 MB or 2 MB application, so it gets installed over there and it opens the Composer file, and they can definitely view all your contents over there. So any other questions from the audience? Okay. So if you have further more questions, definitely feel free to connect with us to have a one-on-one session, and we can make sure all your queries are being addressed at your uh, office location itself. Yeah. So let me go for the last poll of the day. Yeah. So would you be interested in hands-on workshop with the 3D experience of tools? So I just want everybody to answer this question. So that's definitely helps us in knowing your opinion and feedback about the 3D experience platform and your interests. So here I can see most of the people are interested in knowing more about the platform. So I have almost like 88 to 90% of people would like to know more about the platform. So I definitely take this as an encouragement, and we would definitely like to reach you out to give you more information about the 3D experience platform and its solution portfolio. I'll be closing the poll right now. So coming to the key takeaways of today's session, so we just saw how 3D experience how 3D experience SolidWorks helps us in creating the real-time designs, and it gives us the whole lot of flexibility by installing it in local laptop or computers directly from the server on the cloud, and the files are going to be saved directly on the platform. So wherein the files can be accessed from any person with a flexible named user licensing option. So just by using a simple ID and password approach, so you'll be able to log in into your platforms, and all your data is going to be completely secured and managed on the platform. So next, we are so the next thing is collaborating with manufacturing suppliers and remote colleagues is much easy, as you can share all your real-time designs in the form of links to your external uh, team members or maybe your vendors. So data can be accessed from anywhere and any device at any point of time. So just by the simple browser based approach, just by knowing your ID and password, so you can log in and check on your data from any device. So it can be a simple mobile phone to your laptops to your tabs, anything can be used over there. And as all your data management process is going to be handled on the cloud, so the IT infrastructure and administration cost is going to be completely reduced, as all the maintenance is going to be taken care by Dassault systems. So uh, this briefs about the overall features of the 3D experience SolidWorks. So thank you team for all your time and energy in attending the webinar. So thank you all and have a good day.